Good morning. My name's Diana Nash, and my role with Energy Sciences is to find optimal energy and sustainability strategies and solutions for our clients. So our team at Energy Sciences wants to welcome all of you. Thanks for signing up. And we want to welcome you to this informative webinar on monitoring-based commissioning, also referred to as MBCx. And some people also refer to it as continuous commissioning. So we're excited about the partnership with Cimetrics in the Analytika platform. And we will be covering the Cimetrics Analytica platform today. Next slide, please. So in today's agenda, we'll be covering an introduction to energy sciences and Cimetrics. We will also be doing an overview of monitoring-based commissioning in the Analytica platform. We'll be doing a live demo of the Analytica system, and we will also cover the value proposition for MBCx and also answer any questions for the participants that they may have. So a lot of collaboration went into developing this webinar. And so Energy Sciences is a leader in energy efficiency consulting with a deep expertise in energy management, retro commissioning, HVAC systems, and other areas. Cimetrics is a leader in analytics technology for automation systems, also with a deep expertise in energy management, building controls, and HVAC systems. Energy Sciences and Cimetrics partnered together after some successful collaboration among the staff in the past. And the Energy Sciences current engineering manager and Cimetrics current vice president implemented Analytika on the East Coast in the nation's capital for critical healthcare facilities like the National Institute of Health. So you might ask, why the partnership? So collectively, we offer complementary skill sets and experience on energy management. We promote advanced technology in the state of Michigan and the Midwest area. We help customers optimize their buildings remotely during a pandemic and provide them with extra tools in their toolbox, so to speak. And we also bring different perspectives to the complete puzzle for our client base. And then lastly, we work together cohesively to save energy and money for our clients. So today you'll be hearing from Tim Griffin, the Vice President of Client Operations with Cimetrics. Tim is responsible for the overall sales and implementation of Analytika, of all Analytika automated fault detection and diagnostics projects. Tim joined Cimetrics in July of 2002 and has led several key groups, including connectivity, sales engineering, project implementation, and account management. Tim earned his BS in mechanical engineering from Union College in Schenectady, New York in 1993. And he brings Cimetrics' extensive experience in engineering and design, as well as the project management of energy upgrade projects for several markets, including institutional, commercial, municipal, for clients across the US. He's held senior positions with energy services companies and engineering firms, including prestigious companies like Honeywell.
Morning, thank you everybody for joining. This is Tim Griffin with Cimetrics. Thank you for taking time out of your busy schedules to join us today and learn a little bit more about Analytika and MBCx. Cimetrics is a 30-year-old company based in Boston, Massachusetts. We launched the Analytika MBCx platform about 20 years ago, in 2000, and we've been building it ever since. We also, as a company, we provide BACnet hardware and software to the BAS industry and end users. So a little bit about Analytika. What does Analytika do? Why do it? And how do we do it? Analytika is an MBCx software and service platform. The way it works is we collect data from an existing building automation system and from any other systems within a facility, including metering, lighting, whatever the systems that exist in a facility. We collect that data 24/7, 365. And then we use AI and machine learning to run over 2,500 algorithms against that data to identify faults and optimization opportunities, energy savings opportunities, equipment faults, scheduling errors, prioritization of faults, calculate potential energy savings. We then track the issues over time and help to manage the fixing or the implementation of the issues. I think it's probably obvious why we do this. We want to help building owners and managers and their vendors and their partners run their facilities more efficiently and effectively. We are there to find ways to make a facility more efficient, to save energy costs, to reduce greenhouse gas emissions, to improve comfort, and to improve reliability and prioritize maintenance issues. How is it done? The data that we continuously collect from the building automation system is pushed up to our Analytika cloud servers where it resides, and that's where we perform the analytics on it. We then feed back the results of the analytics to the customer through a web portal that I'll show you next. And also a dedicated Cimetrics analyst and energy engineer, and also a team of mechanical and controls engineers help to go through the results of the MBCx, the automated faults that are found, and we then meet with the customer and go through that. A little bit about Analytica and its history. Again, we started in 2000. It is the most mature, robust, and complete and powerful MBCx software and service on the market. We at Cimetrics set up the software and the Analytica platform for each site, as opposed to just the customer purchasing software and setting it up themselves. We offer the full service ongoing consulting option. It is sold as a software only option, but we find that in most cases we are asked to do the service turnkey. It's fully scalable from, like it says, from 20 points up to 200,000 points. Benefits, again, energy savings. We find the hidden energy wasting problems. We do that through AI and machine learning analytics that no person or team of people can do. You could sit down at a BAS and look all day long and only get through a fraction of the information that exists there, whereas we look at all points continuously from a BAS. Again, reducing greenhouse gas emissions, which is a key element of facility management today. Comfort, reliability. Analytic is a good M&V tool when performance contracts or other energy projects are implemented. Helps prioritize preventive maintenance, O&M prioritization as well, and then regulatory compliance for hospitals, pharmaceuticals, etc. And of course, it also supports utility incentive programs and LEED. Owner's challenges. Those of you who are involved in facility management know these well. I won't go through the list there, but you can see that obviously folks who run buildings have a lot of challenges, and we basically have tailored Analytica to help with each of these. How it works a little bit more in depth. At the left-hand side here, you see the building itself. We then collect the data with the cached poller, the Analytica cached poller, and like I said, we push that data via the internet to our cloud servers over there on the right-hand side of this diagram. And that's where the analytics and the storage of the data take place. And then we feed that results of that back to the customer through a web portal. Again, this is just another infographic on the same process that we go through. We collect the information from the site, we analyze it, we advise the customer on our findings from the analytics, and then we help the customer to act to implement the findings and generate the savings, improve comfort, and yield the other benefits of a continuous commissioning. Just a small sampling of some of the algorithms that we are running against the data. Like I said, we run 2,500 algorithms. Basically anything that can go wrong in a facility, we're going to find it by analyzing the data. This just gives you some idea of the types of things we're looking for by category. But of course, there's thousands more than are shown here. Just a few case studies, some facilities that we've done in the recent past. I won't go through the numbers, but we can do large facilities, we can do medium-sized facilities. annual energy savings is typically anywhere from 5 to 20% in a facility that we can identify, and then work with the customer to implement those fixes to achieve those energy savings. We are paid a flat fee for our service, so the simple paybacks and the net present values you see there are basically the energy savings compared to what we were paid for our service for these facilities. Just two more here. I'll let you read through it. I won't go through the details, but basically, like I said, the number of points is, we can scale up to large facilities or scale down to small facilities. The results really speak for themselves. There's always inefficiencies to wring out in buildings. And again, the inefficiencies in the energy savings is just sort of the monetary justification for the service, but there are other non-monetary benefits like comfort, reliability, etc. So now I'm going to switch over to our demo and show you a live site that we have. And Lexi, any questions at this point that we should pause for?
At this point, we don't have any participants. If you have any questions, feel free to send them over and we'll get them answered for you. Oh, here, one just came in. Are those paybacks exclusive of any utility rebates?
Yes, actually, those payback numbers that we showed there did not include any utility rebates, and we are seeing more and more these days that utilities are willing to pay for not only the cost of the fix for the ECM that we identify, but for a lot of utilities, they're actually paying for our service as well, because they see our MBCx service as a type of study, what traditionally they used to call an engineering study or a retro commissioning effort. They see our continuous commissioning or MBCx in the same way that they would see that study. So they actually cover the cost of our service fee as well as the cost of the fix for the ECM, of course, usually up to the energy savings of the ECM. But yeah, those numbers actually did not include any in those 4 cases there. So
great, thank you. We have another one here, real quick. For new projects, what phase of a project's life cycle is the ideal/advised time to engage Cimetrics? How do the plans and specs specify Analytika? How does Cimetrics provide guidance to the design team?
Yep, that's a great question. So the earlier the better for us to get involved. Certainly we can get involved in any phase of a project, from the very beginning of a design phase for a building all the way up through, obviously we go into existing buildings that have been standing for 40, 50 years. So we can join at any time. The ideal time is the earlier the better in the process, so that we can, in some cases, we can give our input on maybe some instrumentation on the HVAC. And we can say, okay, if you're going to value engineer some of the stuff out, you should not value engineer this temperature sensor out, because that's critical for checking on the operation of the equipment once it's running. So we can give our 2 cents on that, and we can also be ready. The earlier we get involved and the earlier we see the equipment and the points list and the instrumentation, the more ready we are to turn on our system when the building goes live and the systems come on. So we're happy to get involved early on. We basically do some, we can sit in on meetings, design meetings, construction meetings, and then we actually start our work in earnest, with Analytika once the building is up and running.
Great, thank you. We're about halfway through, so we'll make sure to get anybody else's questions in at the end, or send you a message afterwards if you have one at the end.
Great, thanks. So hopefully you can see my screen. This is the Analytical Portal. The portal is a typical URL. You can get to it through any web browser. Each user of Analytika has a username and password, and that user account will give that person access to their workspace. A workspace can be a building, a campus, or a set of campuses. So we can set up access to different facilities or groups of facilities for each user. In this case, I've logged into our demo site. This is an actual pharmaceutical campus in the Mid-Atlantic area. And this is a real site of ours up and running today. We took their name out so we can use it as a demo site, but this is a live site. Right now we start on the home page here. I'll just show you, give you a quick overview of most of the pages here. And we'll go through the executive dashboard, the issues page, utility manager, favorites, and graphs. But starting on the home page here, when you log into the portal, you will come here, and this is basically some project information that it is just here for summary and informational purposes. These are the different modules of Analytika that are being used at this site. The number of points we're polling continuously, 20,000 points from the building automation systems at the campus. And we get 4 data samples per hour, ideally, for our analytics. We like to take the present value of every single point once every 15 minutes for a total of 4 per hour. Assuming the system can handle that, and we're very careful to make sure that the systems can handle that, and the networks and the servers and the devices. We've been doing this long enough that we know the pitfalls and what to look for, and we know to tread lightly on certain systems. So we're very sensitive to that. We've got the whole connectivity piece of this down to a science after doing it for so long and finding all the gotchas. So in this case, we are taking almost 20,000 points from the system. Analytika is then computing an additional almost 61,000 values from the 20,000 that we're polling. So these are intermediate values that are used in our algorithms. We've hard entered into Analytika almost 1,700 values. These are things like horsepowers for pumps, CFMs for air handlers, etc. These are things that we would get off the drawings and any other documentation that is made available to us. So these are constants that do not change over time, as opposed to the dynamic data we are getting from the system in a live fashion. So the total number of data points we're analyzing at this campus is almost 82,000 points. Just to give you a sense of scale, the buildings that we're monitoring at this site, these are building numbers. They number their buildings at this particular campus. To give you an idea of the size of the buildings, the number of points per building. Like I said earlier, Analytika can be applied to a small building. It can even be applied to a single air handler if you wish. And it can also be applied to our largest building is over 2 million square feet, so very scalable. The total monitored equipment for this site as a summary across the campus, just again to give you a sense of scale, 94 air handlers across these 12 or 13 buildings, a number of boilers, chilled water pumps, etc., right down to 1,500 VAV boxes, over 1,200 control valves of different varieties. Right down the line. I won't go through them, but obviously all the HVAC and other ancillary equipment that exists on the BAS, we get data for that equipment and our algorithms run against it. So we're seeing everything operational in the building. If I wanted to, I could launch here into some summary tables. I won't do that today. That's a little bit more in depth, but from this homepage, I could look at some high-level summary fault tables for each of these different categories of equipment. So that's basically the home page. There's more there, but let's move on to the executive dashboard page. This is what it says, basically a high-level overview, savings that we've identified, annual savings that we've identified, and then the annual savings that has been implemented by the customer and their vendors and partners. As we identify it, we relay the information to the site and their vendors in a team fashion. And they go off and do the fixes, and then we verify that they did the fixes. We check the data to make sure that the fixes were actually complete and that the equipment is operating the way it was meant to operate after the issue was addressed. We break that savings down into categories, and we can modify these for anybody's particular site. In this case, it's controls issues, mechanical issues, and scheduling issues. And then the number of issues, and obviously the implemented and not implemented savings for each. So we can kind of, at a high level, again, a high level overview, a snapshot, kind of see where things stand on this campus. That's high level. The next page is the really detailed, in-depth view of Analytika. So we go from one extreme to the next. This is the issues page. This is where all of the results of the analytics are actually shown. And it'll load here. Basically, we have diagnostic by equipment view, and we can change that view to a lot of different other views, and you can create your own custom view so that when you log in, you're seeing the subset of issues that you want to see. If I were to go here and take all of my pre-existing filters, my default filters off of this list, we'll see down an issue total down here at the bottom once this loads. And this is going to be all of the issues that were found at this campus by Analytika, and we see 1,451 issues. And now we call them issues, but you can think of them as faults. You can think of them as ECMs. You can think of them as an item that we identified that should be addressed or could be addressed. So 1,500 different issues. That's a lot. That's a big pile of issues. How are you going to get through that? Well, it's through this filtering, and we typically do this for customers, but certainly customers and their vendors and partners can do this as well. You could come through here and filter by all sorts of different statuses and building and priority. If it has evidence in the last 24 hours, was it occurring for more than 3 days, more than 10 days, etc. And was it occurring for more than, say, 25% of the time? And then you could also go by issue type. These are all the different issues that we have found here. And you could look at a subset of issues or a single issue. So you can filter that way if you're interested in a particular thing. You can also go by equipment category. And you could also go by actual piece of equipment here. I can say, show me all the issues for this particular VAV box or that particular air handler. The other thing you could do is go by equipment type, again, equipment category. And there's lots of other ways to filter here. I won't go through all of them, but suffice it to say that you can really manage your way through this large list of issues pretty easily. I'm going to change the view here really quickly just to focus on savings issues. These are issues that were found by the system, and then one of our energy engineers at Cimetrics actually calculated the amount of energy waste associated with that issue. And I just want to highlight that whenever you see a dollar figure in Analytika, what you're actually seeing is an annual energy savings figure that we have used local weather to weather normalize. So we use the 30-year average weather for a particular geographical area, wherever the facility is across the world. And we weather normalize the savings, and we also annualize it. So this is an annual number. So for this particular issue, they're wasting $11,000 per year because this valve is leaking and it's causing simultaneous heating, preheating, and cooling in the air handler. So we've in order to compare apples to apples, we annualize everything to say, okay, this issue is $11,000 compared to the other issues. Have they actually wasted $11,000? Well, they would have if this issue has been occurring for a year, and they will in the future if it does occur for a year if we didn't find it. So and they also will save that amount of money for the next year once they fix it. So that's a little bit about this energy savings dollars here that you see in Analytika. Some summary information up here about the issues. I won't go through all that, but it's there for when you want to dig through and summarize. I'll hide that for now. And let me click into an issue here and show you the details of what an issue actually looks like when we find it. So this is the detail page for that particular issue. That issue was air handler 8.6 had leaking valves causing simultaneous preheating and cooling. Here's our recommendation. The pilot positioner needs to be tuned. In this case, the site did some investigation, and all this text you see in blue is actually feedback from the customer. They went and they looked at it, and they ordered parts, and et cetera. So this is all memorialized in the portal for everybody to see. So this is either the customer or their vendor who have written in here what actions are being taken. And again, it's here for everybody to see, whether it be management or facility manager, energy manager, us on our end, partner companies, et cetera. And other summary information up here, the savings with the equivalent of the metric tons of CO2 and the electric and the gas breakdown here, and then any activity that was done to this issue recently. I'm going to scroll down so that we see more of the detail down here. And so there's these 5 tabs that give you all the information about this issue. We'll go through them really briefly here. The first tab is the description. And it is what it says. It's a general description of the issue. Again, this blue text is from the customer. They came into the portal and wrote these notes in here. This black text is from our analyst and or our automated algorithm that initially found the issue. Here's a list of the actual points from the BAS on site. This is the This is the point name for the outdoor air temperature that we're using for this issue, and that is the actual point name from the site. So the building operator can go in there and check their system using this point name, which cross-references to our point name here. Over here on the right-hand side, you see we can attach anything. We can attach live graphs. In this case, we've attached these 2 live graphs. We could also, in this case, we attached a screenshot from the front end, and this is for reference, so everybody sees the air handler schematic and where the coils are and where the temperature sensors are. This can be updated or replaced, and you can actually put a photo. You can attach a photograph here if you had a photograph of the coils that you wanted to attach. So lots of leeway there on ways to customize this and put information in here for everybody to see as everybody's working together to solve this issue. Over here on the left-hand side, I won't go through it, but there's a lot of, you could assign a new owner to this issue. They will get an email. You can set up a task for this issue. Say, go order a new part, and a person will get an email with that task. So it works together with your work order management system on site as well. I'm going to go through the next tab here, which is the evidence tab. And this is really a peek under the hood of our analytics. This is actually the logic that went into identifying this fault. These are 6 of our algorithms that run continuously, and these 6 algorithms all tripped at the same time. Wherever you see yellow here across this time span, wherever you see yellow, that fault was occurring. So you can see that 1, 2, 3, 5 of these faults were occurring simultaneously through the winter months, and then they took a break in the summer, and again they're happening in the winter. So it seems to be a seasonal issue, but again, this is all automated. This is the output of our automated fault detection. Our system said, hey, these 5 things are happening at the same time, and down here is the logic flow diagram that says these things are happening, therefore the result we've determined is simultaneous heating and cooling. So this all happens automatically and gets served up to the customer and our analysts in-house. Interestingly, I can go to the actual data behind this. If I click on this evidence bar here, I opened it up in a new tab. I'm going to go to this new tab, and it's going to show me the actual graph of that data for that algorithm, for that part of that fault. I'll show you a little bit about the graphing capabilities of Analytica while we're here. All graphs work the same way, and we've designed it to be very user-friendly. You could think of this as trending on steroids because we have all of the data from the BAS. It's all here, it's all at your fingertips, and we've got tens of thousands of graphs that can be created easily. I'll just show you a little bit about the graphing capabilities. This graph shows about 7 or 8 points in it from that one algorithm, but I can turn points on and off here by clicking on them down at the bottom. I can go to if I hover over, I see the instantaneous values with the timestamp, and as I move, those values will obviously change to show me the instantaneous values. I can go to an earlier time frame here by skipping back here. So now I'm looking at an earlier time frame. I can also zoom out to get more time on this graph. So instead of looking at about a 1 month, now I'm going to be looking at 2 months of data. And conversely, I can either zoom in or go to a later time frame. So you can really move around the data. And then other nice thing you can do, which is really, really powerful, is you can customize this graph. I can add any one of these other points here. We have all of these points for that air handler, for that particular air handler 8.6. We have 40 or 50 points that we're gathering data for, or that we're calculating data for. And I can add in, any one of these points I want to that graph by just clicking on them here. I could also change the time frame here. There's a lot more here in terms of the graphing capability, but just to give you a sense for, really, it is quite powerful. The other thing I can do, and this is true of anything you see in the portal, I can download the graph as a PDF, a JPEG, etc. I can download the data from the graph. I can download the data behind this graph. I can download the points list from this graph. I can save this graph. So everything is portable. Everything from the portal is portable. You can take it in multiple formats. You can take it in tables or PDFs or CSVs or Excels. You can take it and use it for other purposes, or send it to somebody, distribute it to the team, etc. So that's a key thing that we've built into the Analytica platform as well, is the portability of the information here. It doesn't just live on this website. You can take it with you and use it. If I close this graph, I'll get back to the issue here, and we've looked at the description and the evidence. I'll go to the impact next, and then after I get through this issue here in another minute, I'll just see if there's any questions out there. The impact is where we show the energy savings calculation, and here you see that we state everything is open book. This is done by one of our energy engineers, and everything is shown here so that the customer, their vendors, their utility can take a look to see how we calculated that energy savings. We show the methodology and assumptions. We show the data that we used for the calculation, where it came from, if it came from monitor data or calculated or estimated or assumed, et cetera, or from a mechanical schedule. We show the rates that we use. These are given to us by the customer, and these are configurable. We can change these at any time. And the conversion factors for GHG emission. And then we actually show the energy engineering formulas that we're using. These are just standard mechanical engineering formulas, so we show them. There's no magic there. And then in the end, we get down to the savings. We break it down by electricity and gas. So in the end, this is where that $11,000 annually comes from. That's the energy savings calc. The resolution is where the information is contained to, what needs to be done. The pilot positioner needs to be tuned, and here's what people have done, tasks were assigned, et cetera. That's a history of what happened with this issue. And then the notes tab is basically anybody that's touched this issue and what they've done to it over time. It gets documented here, whether the diagnostic engine is our automated fault detection diagnostic engine, or a person, whether it be somebody from Cimetrics or from that are working on this issue. As you can see, everything is here and saved for all time for everybody to see. So that's a sort of a quick dive into one of the issues in detail. I'll go back to the issues list here. Are there any questions up to this point, Lexi?
There are. So here's the first one. How could Analytika be used to conduct academic research by creating a digital twin for comparison to actual buildings to study optimization?
Yeah, so that's basically what we do in Analytica. We actually create a model or an emulation of the equipment in the building within the Analytica diagnostic engine. The way we do that is we populate our database with the points that we get from the BAS. So when that set of 30 or 40 points from that particular air handler we were just looking at, when we populate our database with those 30 or 40 points, our database now knows what type of air handler that is, what kind of coils it has, what kind of valves it has. We have all of the operational information from that, the signals, the positions, the flows, the temperatures, the pressures. So our system compares the ideal operation of that equipment versus what the data coming in from the site says it's doing. And so we actually do a comparison between actual and ideal, and those are the algorithms that run that identify the faults.
Awesome. When estimating savings, what are you baselining the systems to? Are you ensuring persistence? What measure life are you assuming? How are you accounting for interactive effects between the individual ECMS shown so you don't overestimate savings when they are interactive effects? It's all one. So we can.
I'll take that in reverse order. Yes, we're very careful not to double dip. If there's a coil problem and a damper problem on the same air handler, we're very careful to tease those apart and make sure that we're not double dipping on savings, because if you fix one, you're still going to have the other issue, and you don't want to consider the savings to come from both. So our energy engineers are very careful about not double dipping on savings when there's multiple issues on the same piece of equipment. And I'm sorry, what was the first part of the question again, Lexi?
When estimating savings, what are you baselining the systems to?
Yep. So basically, we are comparing to ideal. If in this case, the issue that we just looked at, the valve is leaking, that preheat valve is leaking. The air temperature is rising as it passes through the preheat coil. And we know how much it's rising because we see what the temperature is before that coil. And we see that it's gaining, let's say, 10 degrees from the preheat coil. And then the air handler has to cool that hotter air down to 55 degrees to deliver it to the space. So we know that, as the air comes into the preheat coil, it should, we know what that temperature is, and we know how much the air temperature is rising. That is the energy waste. The amount of energy that's being added to that air is the energy waste. So that's what we're calculating. So we're basically, when we find a fault, something is broken or not working properly in the air handler. Same thing for an economizer issue. If the economizer is bringing in too much outdoor air and it's too hot and humid, our energy savings calculation will say, well, if that outdoor air damper were acting properly and bringing in the correct amount of air, we know what theoretically that would be, and we compare it to what is actually happening. So it's basically the actual operation using all of the parameters that we're measuring compared to what it should be.
How are you ensuring persistence? What measure life are you assuming?
So most of our contracts are long-term. This sort of software platform works best when you look at things long-term. So we've been in buildings for 10 to 15 years. In a couple cases, close to 20 years. Once we go in and we identify all of the existing issues, they usually get addressed within the first year, and then we sort of go into maintenance mode where we're keeping an eye on the system, and we're making sure that the fixes that were done stay in place. We are in a university in Boston here. We've been there for about 12 years. They fixed an issue with an air handler in 2009, and the issue just reoccurred a couple months ago, and we saw it. So that damper issue that happened 11 years ago, and they fixed it, it occurred again, and we found it. So the long-term keeping an eye on things and monitoring is the key. As long as we're connected, our system will automatically look for the issue. It'll look for it. This is sort of semantics. It'll look for it as a new issue, or it'll look for it as a reoccurring issue that has happened in the past. It sort of doesn't know the difference. It just knows that there's a problem. But we can see that, oh, that's the same problem that we saw, last month or last year. So in terms of the issues staying fixed, it's basically our system staying in place over the long term to keep an eye on it.
Awesome. Can Analytika estimate and project future potential issues based on historical/weather data to inform maintenance staff to be able to predict and fix before issues arise?
Yes, so a couple different ways we do that. A whole bunch of some of our algorithms look for oscillating equipment, so oscillating dampers, oscillating valves, things that will, operation of equipment that is not optimal, that's going to perhaps shorten the life of that equipment and burn out the motor. So our system will find that and flag it so that preventive maintenance can be done to prolong the life of that equipment that might have otherwise died prematurely. So that's one way we help with preventive diagnostics. And another thing we do is we do keep an eye on the weather. And if there's severe weather, the system will send out alerts, either severe cold weather or severe hot weather. On both extremes, we'll send out alerts that say, hey, you're going to be sub-zero for the next 3 days according to the weather forecast. Here's what your heating coils are doing today. Here's which heating coils appear to be starved or at 100%. And the temperatures are not being maintained on that outside air damper. So, you might want to keep an eye on that. So we send those tables, as the weather event is about to occur. And same thing on the hot side. Your chilled water is not. You might want to lower your chilled water temperature you're delivering because you're not keeping up with demand. So, yes, we do keep an eye on that. And that's not to say that we are an alarming company. But it is to say that we have the data, and our system is set up to do that sort of thing. Yep.
Can your system be used to monitor and control lighting and user power systems as well as HVAC equipment?
Yes. Monitor, yes. Control, no. So that's actually a good question. That's something I should have mentioned before. Analytica is a read-only software platform. We only take data from systems and analyze the data, and then we feed back the results through this web portal that you're looking at. We do not perform any control. We do not change any parameters in any system, and that's by choice, by design. We are a read-only and analyze software platform. Some software platforms out there, change set points when they want to change the operation of the equipment. We do not do that. We just advise and then recommend. So for lighting and power systems, yes, we have lots of algorithms that look at lighting systems, power systems. We also do process equipment, water for injection, RO, compressed air, basically any building system that exists, manufacturing equipment as well. Any system that exists that has some sort of automation system on it, whether it's industrial or commercial or HVAC, of course, as long as we can get the data into our system from the site, we can do analytics on it, and we have done analytics on it. Lighting is something that's getting more and more traction. Power systems, yes, we do a lot of work in data centers around power systems. So and that obviously ties into the HVAC as well for those. But yes, any system in the building we can analyze and do.
Great, thank you.
Okay. Just a couple more things really to show you here on the portal, and then we can wrap it up for other questions. The utility manager page that I'm going to now is our meter dashboard. And this campus has these 12 or 13 buildings here, and each row is a building, and you're going to see a total energy use for that building, and then all of the commodities that go into that total, like electricity, chilled water, hot water, steam, natural gas, oil, water, compressed air. So this is a pharmaceutical campus, like I said, so different buildings have different metering and different utility usage, and we've captured it all here. In cases where there are submeters, you'll see a little number here with a little meter glyph. And if I click on that, you'll see the 4 submeters in this building. And so this is basically, and you can do a lot of neat things here with the data. You can change the units up here. You can do comparison to previous month and previous year. You can also input, we can input for you, or you could input any other energy profile you want. You could put in a budget profile. You can put in a projected profile. You can put in, whatever 12-month profile you want, and then do a comparison against that in real time here once you've entered it. Any other thing that you would enter, in this case, they entered a baseline for electric. So you can do this comparison to baseline here. But again, there's, budget, baseline, projected, whatever you want to enter there. So that's Utility Manager. There's a lot more to it. I just want to breeze through the rest of this real quick. We can come back for questions. The favorites page is a place, and each building has its own subcategory here, subpage. Basically, any graph that you've created, any graph or table that you've created over time that you want to save and look at later, you can save it to your favorites page. And then when you log in and you go to your favorites page, there's going to be all the different graphs and tables that you've created in the past that are there waiting for you to look at live. So as you come through here, you can see what people have created for these various different buildings. And then obviously, if I were to click on these, this would open the graph live, and I could navigate through the data like I did earlier, where and there's this instantaneous live view, but I could open this up and have it be full screen and navigate earlier, later, and zoom in and out like I did before. The graphs page is the last one I'll show you today. Basically, like I said before, all of the data from the system is here, all 80,000 points in this case for this campus. And there are 1,600 pages of graphs available, default graphs. Now you can create any graph you want from scratch using the data, but there are 16,000, there's 10 per page and 1,600 pages of graphs that are available to you to create at the click of a button. And the way you can drill down into what graphs you want is by this hierarchy of building, category, commodity, floor, zone, which we call a room is a zone, and then piece of equipment. So you could come through here and say, for that one we were looking at before, building 8, air distribution, and I want to look at, air handler 8.6. These are all the graphs. There's about 9 or 10 graphs available for that air handler that we were looking at before. And if I were to click on this, it would go to a similar graph to what we were seeing before for that air handler. And having launched into that graph, I could then add or delete points like I did before. So the graphing capability is humongous here for all of the data. Again, this is 80,000 points that you can look at and visualize any way you want. I'll stop there. It's 10:51, so we're running a little bit short on time. I just want to give more time for questions. Should I pop back to the? Let me pop back to the PowerPoint here. So we left the PowerPoint to go look at the live demo, and now I'll hand it back to Diana.
So I'm sure everybody learned that listened in, what a valuable asset the Analytika platform could potentially be for your organization. And so everybody's looking at it, I'm sure, from a little bit different perspective, either as an educational tool or a tool to help run their buildings, for reporting to their management team. But as we learned today, the Cimetrics Analytica platform delivers a multitude of solutions that can address numerous energy efficiency, ECM operational measures and reporting. So they offer real-time web-based remote analytics and data visualization for HVAC data. The platform reduces energy, thereby reducing energy operating costs. They improve comfort and indoor air quality for the building occupants, and of course reducing GHG emissions is a significant benefit to the community as well as the building owner and occupants. It's something that's a huge topic these days. It also enhances and prioritizes operations and maintenance efforts. So for building facility managers, it's a great tool. It supports regulatory compliance, which is becoming more and more of an issue given our current situation. And the Analytica platform increases reliability and resiliency, which uncovers potential equipment problems and also identifies profitable retrofit projects. The platform documents facility operations, making measuring, verifying, tracking, and reporting easier. And lastly, the Analytica platform provides a means to manage vendors. So all of these are really make up the value proposition for the platform.
We do have quite a few, more great questions here, so we'll go through these. Is there a knowledge management system that will trigger and provide decision support?
So basically, we have basically human analysts who provide that support. These are analysts who have been, using Analytica in-house here at Cimetrics for, on average, over 10 years, 15 years. So there's not a sort of a written web-based knowledge forum per se, if that's what the question's getting at. But our analysts are always available to answer questions and guide folks and give training, and that's how we handle that.
Have you ever integrated with an app to enable remote support for repairs or commissioning?
Yeah, so we can connect with other apps through APIs. We do that on a custom basis. So yeah, our system can dovetail with whether work order management systems or preventive maintenance systems. Yes, we can tie in together.
Can your system monitor renewables or on-site generation systems?
Yep, we've done that in some cases. Again, the data has to be available. If the system has an intelligent data aggregation system attached to it, we can get the data from that system and then analyze it. Renewables like solar, if the solar array in the parking lot or on the roof again has measurements available, we can take those measurements and then we have algorithms to look at it. And it's not only in that case, it wouldn't only be about finding problems, but it would be documenting how the system is doing. And when you look in at the utility manager, you would see how much energy is being generated and how much is being maybe sent back. So yes, it all comes down to the data. If there's data there and we can get our hands on it and get it into our system, we can do anything with it. And in most cases we can. Now, if there's a standalone system that's not networked and not connected and just sits up there and does its own thing, we could possibly try to get the data by installing some new equipment on it. But as it sits there, we can't get it. We can't get to it. So yeah, there are limitations, but yes, we do.
Awesome. We have one more question here. If anybody has any more, please send them on in. How often does the software update? Hourly, 15-minute intervals, etc.?
So basically, it's real time. If I were to log into the portal, I would see data pretty much up to the last few minutes. The way we get our data, which I didn't really talk a lot about today, was we have a data collection device. It's a small piece of hardware. It can also be virtualized. If an IT department wants us to put the software on one of their virtual machines, we can do that. So this either software or this little piece of hardware is the thing that collects the data from the systems in the building. So it'll sit there and all it does is collect data continuously. And then every few minutes, it will upload that data to the Analytica cloud server. And that's where the analytics happen, is on our server. And if you were to log into the web portal and log into your workspace, you would see basically all of the data that had been recently uploaded from the site. So it's more or less real time. There's a little bit of a lag, a few minutes, and calculations don't run continuously. The major calc engine runs overnight. So you can think of it like every day the calculations are refreshed, but the major calculations. But yeah, the data is available pretty much in real time.
Awesome. That's all our questions for now.
So thank you, and on behalf of the Energy Sciences team and Cimetrics, we'd like to thank you for participating and look forward to assisting you in making a choice about monitoring-based commissioning platforms. And also, we're available to evaluate if it's a good solution for your organization. So I want to thank Alexis DeRocher and Tim Griffin for putting all this together, and it's a lot of content, and we really appreciate everyone's participation. If you have further questions or need further information, my contact information is on this slide, and so please feel free to reach out.
Thank you, everybody, very much for joining today. We really appreciate your time. And certainly reach out with questions or if you have any needs in this area.